Hi everyone, welcome back to Smart Civil Engineering. Have you ever noticed cracks appearing on the walls of your home and wondered whether they're harmless or a sign of a serious structural problem? Wall cracks are one of the most common issues found in buildings. They can appear in newly constructed houses, old buildings, apartments, offices, and even large commercial structures. While some cracks are completely normal and only affect the appearance of the building, others may indicate foundation movement or structural failure. The challenge is knowing which cracks are harmless and which require immediate attention. In this video, we'll discuss the most common causes of wall cracks, how to identify dangerous cracks, and when you should seek professional advice. Let's get started. Are all wall cracks dangerous? The simple answer is no. Not every wall crack means your building is unsafe. In fact, many cracks are simply cosmetic and can be repaired without affecting the strength of the building. Generally, wall cracks can be divided into two categories. The first is non-structural or cosmetic cracks. These usually occur in plaster, paint, or brick joints and mainly affect the appearance of the wall. The second category is structural cracks. These develop because of problems within the structural elements of the building, such as foundations, beams, columns, slabs, or load-bearing walls. Structural cracks should never be ignored because they may reduce the building's ability to safely carry loads. Before attempting any repair, the first step is always to determine why the crack occurred. Repairing a crack without fixing its underlying cause often results in the crack reappearing after a short period. Now let's look at the most common causes of wall cracks. Thermal expansion and contraction cracks. One of the most common causes of wall cracks is temperature change. Every construction material, including concrete, bricks, plaster, and steel, expands when heated and contracts when cooled. Although these movements are extremely small, they occur every day. During the daytime, sunlight heats the building, causing the wall materials to expand. At night, the temperature drops and the same materials contract. This continuous cycle of expansion and contraction creates internal stresses within the wall. Over months and years, these repeated stresses can eventually produce small cracks. Buildings located in regions with very hot climates or large temperature differences between day and night are especially susceptible to this type of cracking. Thermal cracks are usually thin and appear near long walls, around window openings, or where expansion joints are missing. In most cases, these cracks are not structurally dangerous, but if left untreated, they can allow rainwater to enter the wall, leading to additional problems. Drying shrinkage cracks. Another very common type of crack, especially in newly constructed buildings, is the drying shrinkage crack. Fresh concrete, mortar, and plaster all contain water. As these materials cure and dry, part of the water evaporates. This causes a slight reduction in volume known as shrinkage. If the shrinkage is restrained by surrounding materials, small tensile stresses develop, eventually causing fine cracks. This is why hairline cracks often appear within the first few months after construction. Drying shrinkage cracks are usually very thin and randomly distributed across plastered surfaces. In most situations, they are cosmetic and do not indicate structural failure. However, proper curing during construction greatly reduces the likelihood of shrinkage cracking. Keeping freshly plastered or concreted surfaces adequately moist allows the material to gain strength while minimizing shrinkage stresses. Dampness and moisture cracks. Water is one of the biggest enemies of any building. Moisture entering a wall does much more than create ugly stains. Over time, it weakens the materials and eventually causes cracking. Water can enter walls through roof leaks, damaged plumbing pipes, external wall cracks, poorly sealed windows, or rising damp from the ground. Bathrooms, kitchens, balconies, and exterior walls exposed to heavy rain are particularly vulnerable. When water penetrates the wall, bricks and plaster absorb moisture and expand slightly. Repeated wetting and drying cycles gradually weaken the bond between the materials. As a result, the plaster may bulge separate from the wall and eventually crack. If moisture continues to enter the wall, paint begins to peel, plaster deteriorates, and mold starts growing. For reinforced concrete structures, prolonged water penetration creates an even more serious problem. Moisture eventually reaches the embedded steel reinforcement. Once the steel begins to corrode, rust forms. Unlike steel, rust occupies a much larger volume. As the rust expands, it pushes outward against the surrounding concrete. This internal pressure creates cracks that gradually widen over time. Eventually, pieces of concrete may detach from the surface, exposing more reinforcement to moisture and accelerating the deterioration process. Therefore, repairing only the visible crack without eliminating the source of water leakage is never a permanent solution. Settlement cracks. Another major cause of wall cracks is foundation settlement. Every building settles slightly after construction. This is completely normal. As the building load transfers into the soil, the ground compresses slightly. If the entire building settles evenly, this movement is called uniform settlement, and it usually causes little or no damage. Problems arise when one part of the building settles more than another. This is known as differential settlement. Differential settlement places additional stress on the walls and structural elements, often resulting in diagonal or stepped cracks. Settlement may occur due to several reasons, including weak or poorly compacted soil, inadequate foundation design, water leaking beneath the foundation, soil erosion caused by drainage problems, nearby excavation work, earthquakes or ground vibration. Settlement cracks often appear wider than ordinary plaster cracks and may continue to grow if the ground movement has not stabilized. If you notice cracks becoming wider over time, or if doors and windows suddenly become difficult to open and close, foundation movement may be the underlying cause. These warning signs should never be ignored. Structural cracks. Unlike cosmetic cracks, structural cracks develop because part of the building structure is no longer performing as intended. These cracks may occur in beams, columns, slabs, foundations, or load-bearing walls, and they should always be taken seriously. A building is designed so that loads are transferred safely from the roof to the foundation. If one structural element becomes overloaded, weakens with age, or is damaged, the load distribution changes. This creates additional stress that can eventually lead to cracking. Structural cracks can develop due to foundation movements, overloading beyond the design capacity, poor structural design, inadequate reinforcement, earthquakes, fire damage, corrosion of reinforcement, unauthorized removal of walls or structural members during renovations. These cracks are often wider than ordinary plaster cracks and may continue to grow over time. One of the biggest concerns is reinforcement corrosion. When water enters structural concrete through cracks, it eventually reaches the reinforcing steel. Steel begins to rust, and rust occupies much more volume than the original steel. As the rust expands, it pushes against the surrounding concrete, creating larger cracks and causing pieces of concrete to break away, a process known as concrete spalling. If this deterioration continues, the structural strength of the member gradually reduces. For this reason, structural cracks should never be ignored. Poor materials and poor workmanship. Another common cause of wall cracking is poor construction quality. Even a well-designed building can develop cracks if low-quality materials are used or construction is carried out improperly. Some common examples include poor quality cement, dirty or excessive sand, incorrect water-cement ratio, low-strength concrete, poor quality bricks or blocks, improper bonding between masonry units. However, good materials alone are not enough. Poor workmanship can also create serious cracking problems. Some common construction mistakes include inadequate curing of concrete or plaster, poor brick alignments, weak mortar joints, insufficient concrete cover over reinforcement, improper compaction of concrete, failure to install expansion joints where required. Many of these problems may not become visible immediately, but begin to appear several months or even years after construction. How to identify dangerous cracks? The next question is, how do you know whether a crack is dangerous? Several warning signs indicate that a professional inspection is necessary. You should seek advice from a qualified structural engineer if the crack is wider than 2 millimeters. The crack continues to grow over time. Multiple diagonal cracks appear around doors or windows. Doors and windows suddenly become difficult to open or close. Floors begin to slope noticeably. Concrete starts breaking away and reinforcement becomes visible. Water continuously leaks through structural cracks. Large cracks appear in columns, beams, foundations, or load-bearing walls. These signs may indicate movement within the structure rather than simple surface damage. On the other hand, fine hairline cracks in plaster that remain stable are generally cosmetic and can usually be repaired without affecting the building's safety. How to repair wall cracks? One of the biggest mistakes people make is repairing a crack without identifying its cause. A repaired crack may look perfect for a few months, but if the original problem still exists, the crack will almost certainly return. Always inspect the crack first before selecting a repair method. Repairing hairline cracks. For small cosmetic cracks, the repair process is relatively simple. First, remove all loose paint, dust, and weak plaster around the crack. Then create a small V-shaped groove using a scraper or utility knife. This groove allows the repair material to penetrate deeper into the crack. Next, fill the groove using a non-shrink crack filler or crack repair putty. After the material has fully cured, apply finishing putty, sand the surface smooth, and repaint the wall. These repairs are generally suitable for thermal cracks and drying shrinkage cracks. Repairing deep or wide non-structural cracks. For wider cracks that do not affect the structural safety of the building, a stronger repair method is required. The damaged area should first be cleaned thoroughly. A grinder is often used to enlarge the crack into a proper V-groove. The groove is then filled using non-shrink repair grout or a suitable cement-based repair mortar. For wider cracks, fiberglass mesh tape may be installed over the repaired area to reduce the likelihood of future cracking. After that, joint compound is applied in 2 coats before finishing with putty and paint. This produces a much stronger and longer-lasting repair than simply applying surface putty. Repairing structural cracks. Structural cracks require a completely different approach. Before any repair begins, the engineer must determine whether the crack is still moving. One common method is to place a monitoring gauge or simply mark the crack with tape and record its width over several weeks. If the crack continues to widen, repairing the surface alone is pointless because the underlying movement has not stopped. Once the cause has been eliminated and the crack has stabilized, several repair methods are available. One common method is epoxy injection. Low-viscosity structural epoxy is injected deep into the crack under pressure. The epoxy bonds the separated concrete together, restoring much of its original strength. For masonry walls, another method is wall stitching. Steel reinforcing bars, commonly called heli bars, are installed across the crack using a high-strength chemical resin. These bars help reconnect the wall and distribute stresses more evenly. However, if reinforcement corrosion is already severe, simply injecting epoxy or stitching the wall may not be enough. The damaged concrete must first be removed. The exposed reinforcement is then cleaned, treated against corrosion, and rebuilt using approved structural repair mortar. Every structural crack is different. For this reason, the repair method should always be selected by a qualified structural engineer after a proper inspection. How to prevent wall cracks. Although some cracks are unavoidable, many can be prevented through good design and construction practices. These include carrying out proper soil investigations before construction, designing foundations according to the soil conditions, using high-quality construction materials, maintaining the correct water-cement ratio, proper curing of concrete and plaster, installing expansion joints in long walls, ensuring good site supervision and workmanship, repairing water leaks as soon as they appear, performing regular building maintenance. Preventing cracks is always easier and far less expensive than repairing them later. Conclusion. Wall cracks are common in both new and old buildings, but not every crack is a sign of structural failure. Some cracks develop naturally because of drying shrinkage or temperature changes, while others may indicate more serious issues such as foundation settlement, structural movement, or reinforcement corrosion. The key is to understand why the crack occurred before attempting any repair. Remember, repairing the surface without eliminating the root cause is only a temporary solution. If you notice cracks that continue to grow, affect structural elements, or are accompanied by other warning signs such as sloping floors or sticking doors, don't ignore them. Seek advice from a qualified structural engineer as early as possible. I hope this video has helped you understand the different types of wall cracks, their causes, and the appropriate repair methods. If you found this video useful, please like, share, and subscribe to Smart Civil Engineering for more practical videos on civil engineering, construction methods, and structural engineering. Thank you for watching, and I'll see you in the next video.